So let's just start here. So welcome along. This is an introduction to Fusion 360 and the product innovation platform. My name is Paul Montford, application engineer with Graitec UK. If you didn't know, Graitec UK now has 5 offices in the UK. We have our head office here in Southampton, where I'm based today. We also have Milton Keynes, Nottingham, Durham and Bradford, and Alex will be joining us from Bradford today on the chat. So our mother company, Graitec, that develops the product Advanced Steel, also has a reseller network throughout Europe and Russia. And Graitec in the UK have recently opened up a reseller in the States. So we're one of the few Autodesk Platinum resellers based in the UK that also has offices in North America. So let's have a quick look at the agenda. We'll start with talking about, well, what if you could redesign CAD from scratch? What would that look like? And then we'll be asking, what is Fusion a fusion of? We'll have a look at Fusion, a preview of Fusion 360, and see how it works for us. And we'll end up talking about the product innovation platform. So let's just start by saying, what if you could redesign CAD from scratch? Okay, so I imagine that you guys are CAD users, use CAD every day. You've probably got features in your current CAD system that you really like. And you might use more than one CAD system. There might be features in other CAD systems that you like, or features you've seen in other people's products that you like. And you think, wow, that would be really cool if I could have that in my CAD system. So if you could redesign your CAD system from scratch and just start again, what would you do? What would you have in your CAD system? And that's what some of the lucky developers at Autodesk got to ask when they started developing Fusion 360. So they could ask us, the public, the audience, you know, what would you keep from your current CAD package? What would you take from other CAD packages if you could have it? This is an interesting question. What platform would your CAD package run on? And if we could do anything in our CAD system, what headaches do we have currently that our current CAD systems can't address, perhaps because of the way they've been developed over the last 20 years? And again, it's another really interesting question. So where does design end engineering begin? What about that handoff? So are we just doing sort of 2D documentation and then having to try and reuse some of that 2D in production? Are we doing 3D modeling, but still really for the purposes of creating documentation, and still with that gap between design and engineering, saving out to a step file or something that has to go into a CAM package? So how do we bring all that together and integrate it? So hopefully I've got you thinking a bit now about CAD of the future, about what you could have in CAD. And this is really what Fusion 360 is. So if you might remember, if you've been using Inventor for a while, that we started off with the Inventor Fusion plugin. This was in Inventor 2010, I believe. And this was like a little preview as Autodesk were trying to work out how best to develop this product. There was a standalone version of Inventor Fusion, a direct modeler. You installed it on your desktop. It came free with Inventor, I think probably to subscription customers first. And then finally, this is where we're at today. This is Fusion 360. This is now the web-enabled version, which runs in a sort of hybrid in the cloud. And this is the version we're going to talk about today. So Fusion 360 is a real departure from our current CAD software. It's really been designed from the bottom up to make use of current technology and what us, the customers, are asking for. So it's integrated. We've got all these different tools that come together. We've got CAM in there, we've got rendering, we've got simulation, all in one tool. And it's connected because it uses this internet backend, partly for A360. And A360 is kind of the document management backend of Fusion. So if you hear me talking about A360, I'm really talking about document management in the cloud. And because we're using that in the cloud, we can give out links to other people can view what we're working on, and we can share and collaborate via the cloud. And it's also accessible for the same reason, accessible via the cloud. You can basically access Fusion 360 from any web-enabled PC, Mac, tablet, phone, whatever you've got. If you can access the internet, you can access Fusion 360. So Fusion is a fusion of what? So Fusion is a fusion of design methods. This is something that Autodesk are going to take away. So we've got parametric design in Fusion. We've got direct modeling in Fusion. So if you like the direct modeling in AutoCAD, we've got that in Fusion. If you like the parametric modeling we've got in Inventor, we've got that in Fusion. And we've also got this subdivision modeling technique. So if you've ever used 3D Studio Max, this gives you a very similar sort of workflow to the way you'd work in 3D Studio. So Fusion is a fusion of all the different modeling techniques you can get. And it's also a fusion of tools. So we have simulation inside Fusion 360. We have CAM programming via HSM Works inside Fusion 360. And we can still create our documentation. We can still create our drawings, and we can do our renderings all inside Fusion 360. So Fusion is also a fusion of platforms. Because it's web enabled, it can run on any platform. So you can install it on your Mac, you can install it on your PC, and in fact you can install it on as many computers as you like. Because you log into Fusion 360 to use it, actually you could install it on as many machines like you just log into the machine you're currently on. So it's accessible from any platform that you want to use it from. And finally, it's kind of a fusion of local and cloud resources. So we mentioned that you install Fusion 360 on your PC, but actually Fusion 360 is using the cloud as a back end. So we discussed briefly that it uses A360 for its document management, but it also can hand off any sort of compute intensive tasks can be handed up to the cloud. The cloud can do those whilst you're still working. So we've got things like CAM path generation could be handed off to the cloud, rendering. So you don't want to tie up your machine with rendering and have to sit there, with the clock ticking and you can't do anything else because your machine's rendering. You can hand that off up to the cloud. Simulation. Graphics. Graphics is an interesting one. Fusion will make use of the local resources on your machine, so it will run faster on a higher spec machine, but it can also hand stuff back and forwards to the cloud. So if you are online whilst you're using Fusion, you can make use of that power. So this all together gives us an integrated product development platform. So Fusion kind of covers everything from the initial stages, the concept development stage. And this to me is quite an important part of Fusion, because if you've used Inventor, you'll know that Inventor is a great modeler when you know what you're modeling, right? But Inventor is not so great for sort of concept design. If you're not quite sure where you're going to go, you can end up building and knocking down a model 2 or 3 times, trying to get it right, trying to make a good model, whilst you're still trying to work out exactly what it should be. So Fusion is much freer, and we'll see how this works. Fusion is much freer for form design. It gives us much more scope at the early stages. When it comes to functionality, we can still produce a bill of materials with Fusion 360. We can produce drawings for Fusion 360. We can produce CAM tooling with Fusion 360. So we can go through to the functional fabrication stages with Fusion 360 within the same package. We don't have to hand off to a separate package to do that. At the end here, we've got manage. So apart from A360, which is the documentation backend, the cloud-enabled documentation for Fusion 360, we also have integration in here to products like PLM 360, which has recently been rebranded as Fusion Lifecycle, and Autodesk Internet of Things platform, which has recently been rebranded as Fusion Connect. So these things allow us to connect into, say, the manufacturing machinery whilst it's running. We'll talk about this a little bit more later. So we can do things like predictive maintenance, and we can also manage the life cycle of our product using Fusion Lifecycle to be able to sort of predictively preempt when our customers might need on-site maintenance or replacement or repair or even a recall of a product. So we'll dive into Fusion now and we'll start having a look at a few of the tools. Before I do that, let me just tell you how to get Fusion. So if you're interested in trying Fusion out, don't do this right now because wait till after the webinar. If you want to sign up, you go here, the web address is here, take a screenshot, put it into the browser, www.autodesk.com products, go to Fusion 360 and you can go to the try buy link. What you'll find is, I just want to point this out to you actually, if you're interested in security and security of the cloud hosting that Autodesk use, there's a white paper down here that you can download that will tell you all about it. Basically it's as secure as your bank, so it's the same protocol as your bank uses for making sure your bank details are secure. So you can't get more secure than that, and in most cases it's probably more secure than your local server, although having said that, it is only as secure as your employees' logins. So okay, that's something to think about. Also here, we talked about Fusion being accessible. It's not just accessible from the point of view that it's an internet-enabled device, it's accessible from the point of view of its pricing. So Fusion 360 is currently free for people who aren't making any money. So students, enthusiasts, hobbyists, startups. So if you're a business and you're earning less than $100,000 a year, then you can use Fusion 360 for free, which is pretty awesome considering what you're getting for the money. If you do want to buy it, then it's £25 a month or £195 a year, which is a really awesome price for what you're getting for your money. That is just amazing. It's not going to be that price forever, so snap it up while it's cheap, that's what I say. So you go to this screen, you click on the download free trial. This will give you a free 30-day trial to try it out. You'll download a little application, run the application, you'll see a desktop icon. So you double click on that desktop icon to complete the installation. And you'll find the first thing it asks you for a login. Okay, if you don't have an Autodesk account, you'll need to go to accounts.autodesk.com/registration and register for an Autodesk account. If you got Fusion 360 as part of the product design suite, then your company that paid for the license of product design suite for you will probably have already created an Autodesk account as part of the login. Okay, so do ask your Autodesk, internally in your company, the account manager for Autodesk, and just ask first, do we already have an Autodesk account? Make sure you use that one for two reasons. Firstly, that means that your license and registration is taken care of by your company. It's all included in the price of product design suite. But also, if you are sharing documents, the documents you have, you'll be able to share them internally within your company. Otherwise, you'll have to share them in another way, which would be slightly more awkward. So just double check that before you create a new account that you don't already have one. So this is what you'll see when you first open Fusion 360. Down the left hand side of the screen here we have our projects. So a project is really a way of keeping information secure. So you can share a project between people, and people can only see what is in that project. You can share a folder within that project or a file, but anybody who can see that project won't be able to see your other projects. So it's really a way of keeping your information secure from everybody else. We'll also see this Getting Started tab. So you'll only see this the first time you set up, and this is just to help you get comfortable with Fusion. So for example, we all know if you use AutoCAD, your scroll wheel goes one way. If you use Inventor, it goes the other way. Well, this is where you can pick and choose how you'd like Fusion to be, whether you'd like to be a bit more AutoCAD or a bit more Inventor. Okay, so just spend some time getting that set up. And finally, over here you've got some samples. Okay, so these samples will be in your A360 account when you open it up, so I encourage you to go through these samples and take a look at kind of what is available to you. There's some nice stuff in there. If you have had Fusion 360 for a while, so maybe if you downloaded this like a year ago for a trial and you haven't gone back to it since, when you boot it up again you might see this sign here says term has expired. That then leads you to pop up this main screen here, and this is when you can sign up to Fusion 360. Now again, just notice here it's free if you're a startup or an enthusiast. Okay, so if you aren't using this as part of a company-owned product design suite, if you just signed up for it just for fun, just because you want to play with it in the evening or tinker at the weekend, you can have it for free, which is just amazing. And I don't think, this is kind of on trust, I don't think Autodesk can tell really who you are. So other than by checking your usage and the amount of data you're pushing through Fusion 360, they're really just trusting you at the moment. So it's quite open as they want people to use Fusion, as they allow people to use Fusion, because they want this to take off. Okay, so we'll jump in now and have a quick look at the different modeling techniques available to us in Fusion. So I'll just switch to Fusion now. Hopefully you can all see this. Let me just make sure I'm in my right place to start. Okay, let's just do a little guided tour before we start. So Fusion 360 will look something like this when you first open it up. Over here in the top left, if you see, this is my data panel. So when I click here, this will show me what my A360 account looks like. So I've got some folders in here, I've got a mechanism I've been working on, and you can see that the A360 is automatically giving me version control. So it's saving every version. Whenever I hit save, it's basically creating a new version, which means I can go back at any point and I can promote this version to current. So if we've made some changes and we're not sure, we can have this back again, and we can also open any of our previous versions. So this is quite a nice way of managing your data, and it's all in the cloud again, so you can share it with other people. Let me just close this. Across the top here, this is our main modeling toolbar, and this is context sensitive. So you saw already, if I switch from model to patch, I get a different set of tools. If I switch from patch to animation, I'll get a different set of tools again. I'm just going to go back to model for the time being. Let me just move my browser over. So let's start with just some of the different modeling types. So we have direct modeling in Fusion. So if we want to create something new, we can just create a new box. So no sketch is required so far. We're creating a primitive. It's just a primitive shape. So I'll click on new box. Fusion will prompt me for a start plane. So I'll select one of my origin work planes here, and it'll ask me for a start point. I'm just going to use the grid here to just sketch out a start point. In fact, I think I'll go this way to start with. And straight away I've got these pull handles, and it's really just pull and push and manipulate. We can just squeeze this thing around any way we like. So these are our direct manipulation tools. We're creating a primitive and then just manipulating it directly to get the kind of shape that we're after. So it's very intuitive, very easy. Now if we have something that's slightly more complicated than a primitive, we can still use a sort of more traditional sketch method. So if I start a sketching tool, again Fusion will prompt me for a work plane, and we just start sketching out. It's very similar to Inventor, even down to the click drag feature that you may have played with in Inventor. So when I finish creating a sketch here, let me just dimension that up. So if I come down to my sketch dimension tool, so I can place some dimensions here. So very similar to the kind of thing we're used to so far. I'll click on Stop Sketch, and this time from Create I'll choose my Extrude tool instead. So this is a bit more like you might be familiar with working with Inventor, to be able to create a sketch, create an extrusion, and then manipulate that. So that's the two sort of methods that you may be familiar with. You may not have tried the last one, which is our subdivision modeling technique. This is from a plugin called T-Splines that was originally developed for Rhino. Autodesk subsequently bought it, and you may have seen this is now in Inventor, but it started here in Fusion. This is the first place they implemented this T-Splines plugin, and so it's gone a little bit further in Fusion than we've got in Inventor. So if I create a new T-Spline solid, first thing you'll notice is I've entered a new environment. So this is a bit like the sketch environment. It's kind of a sub-environment within the modeling area. I'll pick OK, and I'll choose to create a T-Splines box. Okay, so we're going to create another boxy shape. Once again, we'd be prompted for a work plane to start. This time, the start point is always in the middle. I don't know why. This isn't a sketch. It's just sort of defining the shape. And again, this is a direct modeling technique. So we're just pushing and pulling and manipulating this T-spline shape. Now, I think of T-splines as being kind of like a hybrid between a loft and a patch. So you can imagine if we took a spline, took a CV spline, so the CVs are those kind of hard lines we get around a spline that we can use to manipulate the curvature of the spline. Well, let's imagine that these are splines going around and about our shape, and if we click on these, we can either edit the splines or we can choose to edit points, and we can kind of just move these things around. So as we, in this case, as we move these splines around, we're creating a slightly sharper, make sure I get the right pull handle, slightly sharper edge to our box shape here. So T-splines, yeah, it's just a sort of, it's a great way of creating sort of organic shapes. It is a technique all to itself, so it is a completely different technique from the direct or parametric modeling you might have tried in the past. But it is really helpful when you want to sort of just throw down some slightly odd shapes. So I'll choose Finish Form now, and I want you to see what happens when I change back into the modeling environment. I'll click Finish Form, and you see here my T-splines is automatically being converted to a B-rep. So this is a set of trim surfaces making a watertight solid. Okay, so we can now continue to operate on this. I put a plane in here. Yeah, so let's just, I'm going to just cut this. So I'll use my Modify tool, Split Body, and I'm going to split this body using this tool. So now I can turn that part of the body off. And again, from Modify, I'll choose Shell. I'm just going to shell this out now to a thickness so we can see what this looks like. Maybe a bit thinner. Okay, that's fine. So we can see that we can continue to perform our standard CAD operations on a T-spline surface in a way that we can then go back and manipulate. So what's interesting about this in Fusion 360 is the feature tree here is kind of a separate entity to the history. So in Inventor we're used to the history and the feature tree being the same thing. In Fusion we have our standard work planes here. We have the bodies that I've created, so this is a multi-body environment, a bit like a part file in Inventor. And we have sketches down here, but our feature history is actually down here. So this means that to get back to an old state, what we can do is play this backwards and forwards. So this is really interesting because this gives us history with something like T-splines, which is a direct modeling shape. So it brings together direct and history-based modeling kind of separately from feature-based modeling. So just to show you how that might work, I can roll back here. I can go back into my T-splines environment. I could maybe make a correction to my T-spline shape. That's fine just to demonstrate. I'll say OK to finish that and finish form. And then I can roll my history back along again and it will reapply those edits to my T-spline shape. Okay, so it's a really nice workflow, particularly for that sort of conceptual stuff if you are working something slightly organic and slightly freeform. Now, I'm going to move along here slightly and talk about parametric design. So what's interesting here is that we do have parameters in the part modeling environment inside Fusion. So if I come out here to modify and choose change parameters, this displays my parameters dialog box. So if I just zoom out a bit so we can see what's going on. So we can see that I've got my box primitive here and I have parameters here, so I could change this box primitive parametrically, which would mean I could start creating relationships between different sizes in the box. I've got my sketch here, so the sketch that I created for driving the size of that extrusion shape can also be driven. And I've got my extrude here, so again we can just parametrically control and edit any of these shapes. You can see the shell is a parametric feature. The T-spline shape isn't, so there are no parameters to control T-splines. We have to do that with direct editing by going in and editing the underlying T-spline shape itself. So we have direct modeling in Fusion that is also parametrically driven, which is a really nice feature. So I'll say OK to these. I'm going to jump through into my next example now. So this is an example I spent a bit longer working on. So I'm still in the part modeling environment and I have a bunch of shapes here I've modeled. We can look down the bottom here and see that I started with a primitive. I've then used some sketches and extrusions to build this shape, patterning, so all the regular features you would be familiar with working with in something like Inventor. At the end I've used some more primitives for creating these pins. Now this is currently all one multi-body part. So how do we then turn this into an assembly in Fusion? Well, actually we do that all in the same environment. So in Fusion, if we want to create a component from a body, it's just a right click. And we see here we've got create components from bodies. And in fact what I'll show you here is that we can create the whole lot. So if I just shift select all my bodies, right click and choose create components from bodies, it doesn't look like much has changed, but what was happened is that we can now move these around as if we're in the assembly modeling environment. So we kind of get the best of assembly and part modeling all within the same tool. So this is a really nice way, again, if you're top-down design, if you're doing your conceptual design early on, you can really kind of throw stuff down in Fusion, knowing that you can convert it to an assembly quite freely later on. You don't need to know kind of quite what you're modeling when you start, like you would do with Inventor. So now we have our parts, we could now begin to place constraints in the same way as we would do with Inventor. Now in Inventor we've got joints. We've had them for a couple of years. They're really nice. I really like using joints in Inventor, but they started here in Fusion. So Fusion is quite often a test bed for new technologies, and they can put it into Fusion. They're updating Fusion about every 4 weeks, I think it is. So these new features come in, they get immediate feedback from people that are using it, and if they're good, they stay. And also if they're good, we get that technology into Inventor. In fact, the Fusion team and the Inventor team are in the same office, so I'm sure they're stealing ideas from each other all the time. So if we want to start constraining these in, under Assemble we've got a joint tool, just like joints in Inventor. Excuse me, I'll just start that again. Joint. So just like Inventor, we can just pick a side, and then we can then pick which feature we want to joint. And again, here's a tip, the same hotkey works in Fusion as Inventor. So if I hold down Control, it'll limit my selection to that one face. So I could make a selection on one face, make a selection on the next face, on my second component. And it's good practice to always pick the component you'd like to move first, and then the component you'd like it to move to second. And in this case, it's automatically giving me a rigid constraint, but actually I'd like to have a slider constraint. And I'd like this to slide in the y-axis, There we go, nearly right. I'll try that again in a moment. So that's how we then start creating constraints within Fusion in order to be able to see that our design works mechanically and make sure that motion works. So let me just flip over. So here's one I've created already, and I've put all my constraints in down here. Currently I've got these suppressed, so I'll just unsuppress these, and you can see we've got them all in there. And if I take you to the top view and click and drag on my little handle, hopefully we should see this all going around. So that's the mechanical motion I was trying to work on, and I'm very pleased to say that's all working just fine. So what's really nice about this is that we are still working in the same environment. So we can go back to our parameters manager and we can change parameters. So I'm going to start with something fairly straightforward. Let's just change the height of this. So you can see how with a bit of thought and encouragement you could put parameters in to control your entire assembly, and they're going to populate from the original part you created through into your assembly design. So again, for a sort of top-down design workflow, this is really helpful, really useful. So let's move on with my final thing I'd like to show you here. Is I'm going to move on and just talk about materials and rendering in Fusion 360. So this is another version of the part here that I've added materials to. Just to show you how that's done, if I come into modify, I can choose physical materials. This pops up a palette. Just like Inventor, we have materials and appearances. So this is my materials here from my Fusion 360 library. Again, this is loading this from the web, so we've got lots of options in here, and we can get more as we go along. So all I've done is I've gone down here till I found something kind of cool. When I found something I like the look of, it's really just clicking and dragging. Let me go right down to the bottom here. So it's really just clicking and dragging one of these options out onto a part, and it just allocates that material to the part. So it's all nice and straightforward. It's dead easy. Once we've allocated materials to parts, we can then take this through into the rendering environment. So I'll just close this window, and I'll switch environments here from the modeling environment through to the rendering environment. So the first thing you'll notice is we have this sort of pre-rendered visual on the screen, so we can have a quick look and see what this is going to look like. We can find a nice view we like the look of. Make sure our view is about right. Excuse me. And I'd like to draw your attention to this bar down the bottom here. So there are some pre-rendered views here that we didn't ask for. Fusion's done these for us, and these kind of come for free, and this is like the power of the cloud, right? Because one processor on the cloud, it costs $1 an hour, or we can have 100 processors for a second. Okay, so because processing is kind of cheap in the cloud, you get these renders just thrown in, which I think is a really nice sort of feature of Fusion. But we can also create our own renders. So in our render workspace, we can set up things like the scene settings, so we can put these IBL environments in like we have in Inventor, put these into the background to add some information. And these come with their own lighting, so these add lighting in. And we can add decals and texture map controls in the rendering environment. Right here we have the option to in-canvas render. So this is going to turn on ray tracing. This is the new ray tracing engine inside GMAX into Fusion 360. And what it's doing here is it's imagining a point of light is coming in through a window and bouncing off our model, and so we get reflections, not just reflections in the floor surface, for example, reflections as things bounce off each other. This looks kind of grainy at the moment. What's happening here is that it's rendering one pixel at a time, and it's rendering kind of randomly across our image. And the reason it's doing that is to give us an idea, sort of preview of what this might look like before we send out the full render. Now this is kind of a image, so I can move this around. I can change the performance options here. So if we do want a, we could just change this to a quick view, just to give us a quick idea. And we can also change things like the camera position in order to be able to give us things like depth of field. I'm going to move on and just show you what you might do when you're finished. When you're finished and you've got kind of a preview that looks about right, you click on render, and then we have the option in the render here, not only to change the size of the kind of thing we're doing and the output that we want here. We've got the choice whether we want to do this locally, so we can make use of our local machine if our local machine is a good renderer. Or we can use the cloud renderer, so we can push this render up to the cloud and have this running on the server whilst we get on with some other work. So this is a really nice feature that's going to sort of save you tying up your machine or clogging up your machine with renders when you should really be doing something else. So let me just close it down, and I'm just going to pop back into the PowerPoint. So we talked about parametric modeling, we talked about assembly modeling, we talked about rendering. That was the render I pushed out last night, so that took about 10 minutes. So again, you see a slight sort of grainy texture. The more iterations we let the renderer do, the sharper that's going to get. So I just did a 10-minute render. That's kind of like a coffee break render just to see what things are going to look like. If you want to get a really great image, you leave it overnight. You leave it longer to generate more pixels. So let's just finish up by talking about the product innovation platform. So all these tools come together in a platform that we can use for developing our product from one end to the other. And to illustrate this, I've got a slide here, and which will just take you through. So most companies would have a sort of linear approach to their product development. And there are 5 sort of key areas which most companies go through on their way to developing a new product. So we start with the design process, and this is where we're familiar with Autodesk offering us the software we use for design. And usually we've got a customer need, or we've got an idea that we think would make a good design, and we'll start working on that with a 3D model and some documentation. And we might get some feedback at this point, do some collaboration with our customers to see whether it's something they really are interested in. And we can also do things like simulation at this point to see if we can work out a cheaper, easier way to manufacture this item. So from design we'll move on to manufacture. Now this might be in-house manufacture, or it might be that we need to push this out to a subcontractor, depending on the kind of manufacturing techniques that are required for the product, and seeing what we can achieve internally. When we've manufactured the item, we can then push this out there to our customer, and we can market it and sell it through the usual channels. We can try and find people that want to buy our product. Now the trouble with this sort of traditional life cycle is that we're in competition with everybody else, and they're all trying to do the same thing. So what we end up doing is competing on price, and it's a race to the bottom with everybody trying to drive down prices. It's really hard to kind of distinguish yourself in the market with this sort of process. So what we're really trying to move on to now these days is talking about product as a service. So for example, Rolls-Royce make jet engines, but you can't buy a jet engine from Rolls-Royce anymore. They only rent them. Okay, so they rent them out to you as a customer. You rent them for a certain number of miles, so you have a contract and you're paying for that contract throughout the use of this lifetime of this product. But in return, Rolls-Royce maintain that product on your behalf. They'll replace it if it breaks. They'll proactively come out and do this, so you don't need to worry about it. Yeah, that's all included within the price. So this takes us from having something that is the traditional Autodesk area of just being production ready to design through into this sort of predictive failure and optimization phase. So the platforms which I talked about earlier, things like Fusion Connect. So this is a platform that allows us to connect RFID tags, for example, to the machinery in our factory. So instead of replacing a motor because it's 6 months has come up, and we say, okay, in 6 months replace the motor, we can actually monitor it through its lifetime, and we can replace it when it starts to become worn. So if we look at its vibration and its heat, we can wait till we can see it starting to fail before we replace it. So internally in manufacturing, we can have more information at our fingertips, allowing us to manufacture these things more effectively. But it also allows us to bring the manufacturer close to the customer. So things like 3D printing allows us to offer the customer more options. So we've all been on Amazon and we've looked at the different books and things that are available, and we've looked at different products, and we've said, well, actually I don't want that in black, I want that in blue. And things like 3D printing allow manufacturers to better design something but still leave a bit of freedom to the customer to better have those options in there. And finally we have the PLM, which is now Fusion Lifecycle, and that allows us to do product lifecycle management. So it's the end-to-end management of our product. So it's not just releasing the product and to our customer and waving goodbye and hoping they'll come back to us if there's a problem. It's actually being able to proactively track the life cycle of that product, be able to predictively go to our customer and say, we understand you own one of our products and it's time it was maintained, you know, could we have the contract for that? And be able to fully manage the whole thing all the way back through until the product is finished and it needs to be recycled or replaced. So product innovation platform is something you'll hear coming from Autodesk quite a lot. It's based on Fusion 360. Fusion 360 is at the hub of all these different things, allowing us one space in which to do all these different processes. And this is the kind of vision from Autodesk for what they want Fusion 360 to be. You know, this is not just a CAD package in the cloud, but it's part of a much bigger environment, allowing us to do our business in a different way and manage our business in a different way. Good. So I apologize, that says PLM 360. I need to update that to Fusion Lifecycle. So thank you very much. If you have any questions, now is a good time to ask them. I can see we had a couple of people said hello via the questions box. If you want to pop any more questions, now is a good time. So both Hans and Gordon just said hello, so hello guys. But if you have any more questions, now would be a good time to put them into either the chat box or the question box. I have put up here a few credits and resources. So again, if you want to take a screen capture of these, you can visit some of these pages. I've put the security white paper we talked about on there. The Autodesk Fusion 360 blog. So if you want to hear about what's new in Autodesk 360, you can go to that page. Let me just see if there's any more sort of questions coming in. So a question from Gordon, why would I need Inventor? Well, Gordon, I think the main thing here is that Autodesk aren't trying to oust Inventor from companies who are already using it. So companies have invested in Inventor, they have Vault, they've maybe used iLogic and customization to build in a backbone to their business. They're not going to ask you to strip all that out to replace it with Fusion 360. Fusion 360 is a great value offering, but it's not really a match to Inventor yet. So I think this is this is me personally speaking, it's my own opinion. I think this is why Autodesk are marketing specifically to startups. So what they're saying is that we understand that we're not going to replace Inventor with Fusion, but what we want to do is have those new companies that are coming in, companies that are just starting up, have Fusion from the beginning. So I think they're really hoping that Fusion will be a sort of mainstream product in a few more years' time. But by then, these companies will have grown and they'll already have Fusion 360 in there as their backbone. So thanks so much for that question, Gordon. Has anybody else got a question? So Warren Parrington, is this recorded? I missed the start, can I download? The question is, yes, I'm recording it, Warren, so I'll let you know. There'll be a link, we'll put it up on YouTube and you better come back and watch the beginning. And Phil just wants to say hi, so thank you, Phil. Hi, Phil, how you doing? I did put a few facts up here. If you've got any more questions, continue to put them in the box, but just to keep things, just keep discussion going. I put a few things in here that the kind of questions we get answered reasonably frequently when we're out on the road talking to customers. So how secure is A360, which is the PDM product data management part of Fusion 360? So as we talked about earlier, it's as secure as your online bank. Okay, so nobody's going to be able to hack in, well, they're not going to be able to hack in very easily to steal your data, but it is only secure as your username and password. All right, so if you're not careful with that, then somebody could use that and access your account. So you might need to have protocols within your company for how that's managed. Can I use Fusion 360 offline? Well, yes, you can use Fusion 360 offline. It is installed on your local computer. You can use it for up to about 2 weeks. After 2 weeks, Fusion will want to contact the Autodesk servers. That's partly to check your license condition to make sure you've got a current license. And it's partly to sync up your data. So those documents you're creating will sync up to A360 and they will be available to you via the cloud. So you've got about 2 weeks before things start to prompt. Will Fusion 360 take over from Inventor? Well, firstly, if your security says you can't use the internet, then Fusion's not going to take over from Inventor. So Inventor is an on-premise package that's going to work for you for as long as you need it to. But if you can use the cloud at work, then you could use Fusion 360. And again, we talked about this already. So if you've already made a big investment in your current CAD PDM software, you're not going to replace it with Fusion 360. You're not going to pull it out and replace it right now. And can I work on my Inventor designs in Fusion 360 and vice versa? So unfortunately, The modeling kernel is the same kernel under the hood, which is great, but the file and the way it's managed is different. So you can export neutral files out of Inventor and load them into Fusion 360, and you can go the other way around, but there's not really a direct link between the two right now. One more question has come through from Gordon. Will there be a price hike as it grows? Will it compete against Inventor? Well, I can't predict on behalf of Autodesk, but I'm really surprised they're giving away that amount of technologies for a price that's that cheap. So I wouldn't be surprised if the price does go up. But again, I don't have any insider knowledge of that. That's just my personal opinion. Will it compete against Inventor? Eventually, I mean, I guess it's got to stand on its own 2 feet and be a product that people want to buy. So yeah, I'm guessing eventually it will be a competitor to Inventor. But although there's some really good, useful stuff in there, particularly if you're a product designer and you just want to go straight from a model to a 3D print, there's some great stuff in there for you. If you are a machinist and you want to be able to open files from any customer and apply tooling to them, there's some great tools in there for you. So there are people right now who can use Fusion as it is, but I think it's not a fully developed platform that would compete against Inventor right now. So any more questions from anybody? So thank you very much for those questions, and if you've got any more questions, please feel free to email me. When we finish the webinar, I'll give you my email address. If you haven't already, please go to Fusion 360, autodesk.com/Fusion 360, and to download that free trial, and then have a go and think of it. It is free, it's not cost you anything to give it a go. Thank you very much, everybody. Thank you for attending. I'm going to close the webinar in a few minutes, but I'll tell you what, I'll just leave the chat box open for anybody who wants to stay and ask any more questions. Thank you.